Alright, in this problem it tells us, given cosine of 2 theta equals 3/4 and theta terminates in quadrant 3, find sine of theta and cosine of theta. So this is the first time we're doing something called double angle identities. Well, how do you know it's a double angle identity? Put your finger somewhere on here where it looks a little bit different. That's the first time you have 2 times the angle. That's why they call it the double angle identity. Well, here's the hard part. For cosine, it tells me cosine of 2 theta equals 3/4, and I'm supposed to find sine and cosine. Well, obviously I can eliminate the tangent double identity because I don't need to find tangent. Now I can look at sine, double angle identity of sine there on the board in green, and then also in blue. You're trying to think about which one to use. Well, notice how they give me some information, so I'm going to write down cosine of 2 theta. And the reason why I'm going to write that down is because that tells me that might be a good place to start. And here's the hard part. Which double angle identity are we going to use? Because there's 3 of them. And you can use either of the 3, but we need to think about which one to use and eliminate. Well, if I use the first one, cosine squared theta minus sine squared theta, notice how that would imply that I would have to have a sine value. And I have 3/4, which I'm going to substitute here, but I don't have cosine nor sine. Okay? Look at the second one. The second one says 2 times cosine squared theta minus 1. I'm going to start there because I can solve for cosine. And I can also use the last one if I wanted to, 1 minus 2 times sine squared u of theta. So I'm going to use that middle one, 2 cosine squared theta minus 1. Everyone say double angle identity. We're going to use the double angle identity for what? Cosine. So let's use our first clue. The first clue is that they tell us that the double angle identity for cosine is equal to 3/4. Well, I see it right here. So instead of writing cosine of 2 theta, class, what am I going to write there? 3/4. And at the same time over here, now I'm going to write cosine squared theta to be a little bit more friendly. Do you see that? That's really what cosine squared theta means. It's cosine theta times cosine theta. And then all we have to do here is just solve. We're going to solve for cosine theta. I can find some other things. To simplify, I'm going to be using PEMDAS. What should I do first, class? In order for me to do the exponents, I'm going to have to clear the other ones out. Someone said add 1. Pay attention. If I add 1 here, this 1 will become what? 4 over 4. Good. Look ahead, right? When I add 3/4 plus 4/4, I get, just adding the numerators, 7/4 equals 2 times cosine of theta squared. What should we do next? Okay, pay attention. When I divide by 2, it's the same thing as multiplying by 1/2. Do you see that? If I divide by 2 here, the 2 is in the denominator, so I'm putting another 2 in the denominator here. Multiply across, class, what do you get? 7/8 equals, my 2's will cancel, cosine of theta squared. And then I just need to get cosine by itself. I have to take the square root. Be careful here. Now I have plus or minus. Remember, when you take the square root of an equation, you have a plus or minus. There's now two solutions, and we'll eliminate one of those later on. The square root of 7 divided by the square root of 8 equals cosine of theta. Can I simplify the square root of 7?
No.
So I have the square root of 7, and the square root of 8 becomes what?
2 radical 2.
2 radical 2. Here I need to rationalize, so I'm only going to multiply by radical 2. Remember, I can multiply any number or expression times 1 and it doesn't change it. Rad 7 times rad 2?
Radical 14.
Radical 14. Radical 2 times radical 2? And radical 4 is 2. So 2 times 2 is 4. I need to pick one, positive or negative. Well, it tells us a hint. What's the hint, class?
Terminate from quadrant 3.
And what do we know about quadrant 3?
Negative
Cosine should be negative. So my answer is, I'll just flip sides if that's okay. Cosine of theta equals negative radical 14 over 4. Notice here we've completed our first one. Now, to find the second one, to find sine, you can do two things. It's okay. Everyone say okay. It's okay to use cosine of theta. What's an easy way of doing the problem to find sine? I can just use a Pythagorean identity. Sine squared plus cosine squared equals 1, right? You can do that, but I want to practice actually using the double angle identities. That way that we get more comfortable with it. So I'm going to try to find sine of theta. Actually, I don't want to use the double angle identity because it doesn't tell us the double angle of sine. So we are going to use a Pythagorean. Let's write that. Pythagorean identity. So over here we use the double angle identity. And over here we use the Pythagorean identity. Sine theta squared plus cosine theta squared equals 1. I'm going to take what we just found in cosine. Remember, up here, this is not cosine. This is the double of the angle of cosine, which we don't know. All we know is just the side lengths. So I'm substituting in here. Sine of theta squared plus negative radical 14 over 4 squared equals 1. I'm going to repeat this one here. Remember, this is this expression multiplied by itself. So class, what's a negative times a negative? Radical 14 squared. It's just 14. It's essentially the square root of 196, and the square root of 196 is 14. Pay attention, this is really 1/4 squared. I know that you think of it as 4 squared, which is what, class? 16. It's really 1/16. And what do you think I'm going to make that 1? Yeah, let's think ahead. I'm going to eventually have to subtract. Let's go ahead and subtract the 14 over 16. I have sine of theta squared equals 16 minus 14. 2 over 16. Now, you are tempted to always simplify, aren't you? But you've learned back at the unit circle, you don't always have to do that unless your answer tells you to simplify. Because look ahead of what we're doing. If I take the square root of both sides, sine of theta equals plus or minus the square root of 2 over the square root of 16. Sine of theta equals plus or minus radical 2 over what? 4. Do you see why I didn't simplify? And sine in quadrant 3 is negative. So sine of theta equals negative radical 2 over 4. So to review the problem, we started with the double angle identity. Write down one of the formulas. Think about what you would do. Here, I could have also used 1 minus 2 sine squared theta to solve for sine, and then we can use Pythagorean identity to solve for cosine. So multiple ways of solving the problem, lots of algebra to simplify.